All right, so suppose that you have a torn tendon and are facing surgery to repair it. The orthopedic surgeon explains the risks to you. Infection occurs in 3% of such operations. The repair fails in 14%, and both infection and failure occur together in 1%. What percent of these operations succeed and are free from infection? All right, so what are we asking for? We're saying we're finding the probability that the operation works, right? So there's no infection and it doesn't fail. So let's take the information that they gave us up here and let's organize it a little bit better. What do we know? So let's say that make ourselves a Venn diagram for what's going on. So we've got infection in 3%. So let's say that this circle represents the infection and it's 3% of the time. 14% of the time the operation just fails, regardless of the infection. So, but notice there's a 1% infection failure rate. So that means that this 14% overlaps with this 3%. So I need to draw my Venn diagram like this. There's an overlapping portion. So this is the failure rate of 14%, but infection and failure is 1%. So if I said, well, what's the probability of either infection or failure? Well, then that's going to be 0.03 plus 0.14 minus the overlap of 0.01. So that's 17 minus 1, which is 16%. So 16% of these operations have trouble. Well, they're saying what percent of these operations don't have any trouble at all? Well, that's everything else out here. Well, if there's a 16% problem rate, then there's an 84% non-infection and a success. So there's our answer to the first one. This one's a little bit convoluted. Look at what it says here at the very end. Suppose that he arrived late once again this morning and had to park in a no parking zone. Find the probability that Joey will get a parking ticket. So this question is saying, what's the probability that he gets a ticket given that he parked illegally? All right, well, this is one of those cases where we might actually need a formula for this. So remember, the formula for the probability of A given B is equal to the probability of A and B divided by the probability of B alone. So in this case, it's the probability of a ticket and an infection, ticket and illegal, I was back here on the infection, divided by the probability of parking illegally. Well, let's see what they told us up here. Those who arrive late park illegally and take their chance of getting a ticket. Joey has determined that the probability that he has to park illegally and he gets a ticket is 7%. Illegal and ticket. So that's 0.07. Over, kept data from last year and found that because of his tardiness, the probability that it would have to park illegally is 25%. That's parking illegally. Well, there's our answer. 0.07 out of 0.25. So what's his probability of actually getting a ticket today because he parked illegally? 0.07 out of 0.25, and that's 28%. Two cards are dealt one after the other from a shuffled 52-card deck. Why is it wrong to say the probability of getting two red cards is a half times a half? Well, because if you get the first red card, half the deck is no longer red, right? So the first red card, that's going to be 26 out of 52. Times the second red card, so that's only going to be 25 out of 51, which is not quite a half times a half. And that's it. So what's the correct probability? 26 out of 52 times 25 out of 51, which is 24.5%.